Hello guys, it's Miss Huser, and today I'm going to go over the test review for you guys. Alright, so here we go with the first one. In this hanger, the triangle is X and the weight of the square is Y. So, what I'm going to do is label each of those shapes. So, my triangle is X, and my squares are Y's. Now, when you guys are taking this test at home, you won't be able to write on the test. So I need you guys to have a piece of paper out while you're taking the test so you can recreate this on a scrap piece of paper on your own, okay? Alright, now it says write an equation using X and Y to represent the hanger. Well, since this hanger is balanced, this side is equal to that side. So, how many X's do I have? 1. How many Y's do I have? 3. So I'm going to add those together, and that's my left side. Now we're balanced, so we're setting that equal to the right. I have 4 x's, so I'm going to write 4x. And then we have 1 y. Alright, so that is our equation. Now it says if x is 6, what is y? So we're going to plug in 6 for x. So we're going to put a 6 in for wherever I just underlined. So we have 6 plus 3y equals 4 times 6 plus y. Alright, I'm going to simplify that. So I end up with 6 plus 3y equals 24 plus y. Now, I like to deal with my variables first. So I'm going to subtract y from both sides so then it stays positive. So I'm going to subtract y. And I end up with 6 plus 2y equals 24. Alright, so now I need to figure out which term on the left is like terms with mine on the right. Well, it would be 6 because 24 does not have a y, therefore, and same with 6. So subtract 6 from both sides, and I get 2y equals 18. We're almost done. Now we need to divide by the term that is connected to the variable. So I end up with y equals 9. Ta-da! Now if you need to go back over any of that, please just pause and rewind, okay? Because I'm just going to crank these out. Okay, so for each equation, determine whether it has no solution, exactly one, or is true for all. So that's what we're going to do. First, let's look at our coefficients. Are they the same? No. So that means it's one solution. Alright, now on this one, let's simplify first, and then we can figure out what we have to work with. So we get 6x plus 8 equals 6x plus 8. When we distribute that 2, we end up with 6x plus 8. Now, don't these look exactly the same? Yeah. So that means this would be many solutions. Okay, our coefficients are the same, and same with our constants, therefore, many solutions. Now this last one. Our coefficients are the same. Awesome. But our constants are different, therefore, this is no solution. Alright, now there's going to be a question just like this on the test. The only difference is that this might be written to look like this. So it just might be organized a little differently, but same exact concept. You might just think in terms of slope and y-intercept rather than constant and coefficient. Same exact thought process, just looks different, but you'd approach it the exact same way. Alright, now down here. So it says the solution to the system is 5, 10. That's my x and my y value. It says select all the equations that could be the other equation in the system. So we need to figure out which one of these equations is the other line or the other equation in the system. So what we can do is plug in my x and y value and for x and y and see if it's true. If it's true, it works. If it's not true, it doesn't work. Alright? So let's do this first one. 10 equals 1/2 times 5/1 plus 8. I'm plugging my x value of 5 in for my y value of 10. Okay. So here we go. We end up with 10 equals 2.5 plus 8, because 5 over 2, if we multiply across, we get 5 over 2, which is the same as 2.5. Now, 8 plus 2.5 does not equal 10. So we know that that is not the equation we're looking for. And it also didn't say, it said select all, so there could be multiple. So we know it's not that one. Let's do this second one here. So 10 equals 3 over 5 times 5 over 1 plus 4. We end up with 10 equals 15 over 5 plus 4. Sorry, I wrote it backwards. Okay, so then we end up with 10 equals 3 plus 4. 3 plus 4 equals 7, not 10. Therefore, this is not our answer. We're going to keep going. Those two were the worst ones because there's fractions, so the rest are going to be super easy. So we have 10 equals negative 2 times 5 plus 20. So simplify that, and we have 10 equals negative 10 plus 20. 20 minus 10 equals 10. So C would be an answer. Now on to the next. Y 10 equals negative 5 plus 15. 15 minus 5 does equal 10. So D is an option as well. Alright. Now this last one we could do in our head. So 4 times x, which is 5. So 4 times 5 does not equal 10. So that would not be an option there. Okay. There will be, once again, there will be a question just like this on the test. Take your x and y value, plug it into those equations. If they work, it's an answer. If they don't work, it's not. Okay, now we're going to solve some equations. So I'm going to add 3w to both sides, so then my variable is positive. So now I have negative 4 equals 4w plus 3. Now which one is my like term to my term by itself? Well, it's going to be 3. So I need to do the opposite of addition. So I'm going to subtract 3 from both sides. I get negative 7 equals 4w. Divide both sides by 4 to get w by itself, and we have negative 7 over 4 as our answer. Alright, now on the bottom here, we're going to distribute because we see parentheses, and that's the first thing we need to do. So now we have 9 minus 9x equals 2x plus 6 minus 30. Alright, now we need to check to see can we combine any like terms. Like terms right here. So if I owe Mr. Huntley $30 and I happen to have $6 on me, so I pay him back $6, I only owe him $24 now. So I would write that as negative 24 because I owe 24 still. Alright, now I'm going to add 9x to both sides, so then I have a positive variable. So I have 9 equals 11x minus 24. Alright, now I'm going to add 24 to both sides, since that's my like term, and I'm going to write my answer over here. I get 33 equals 11x. Alright, now you need to divide by the number that's connected to your variable. So divide both sides by 11. That would be 1x, so we're left with x equals 3. Once again, if you need to pause as I go through these, do that, so then you can get everything down, or just go back over. But ultimately, you needed to have this done before class today when I went over it. So you should just be kind of checking your answers and listening to how I solved it if you maybe did it incorrectly. So that's why I'm kind of going fast, because you should have this already done. Alright, down here, we got fractions. This one's the most similar to the test because the one equation you're going to have to solve has fractions. Okay? It's not just like this, but there are fractions. Okay, well, my denominators are the same, so I could multiply each term by the denominator to get rid of my fractions. And the only reason why I can do that is because both fractions have the same denominator. So I'm going to multiply everything by 3. So I can't forget about that 6 as well. So if I were to multiply here, my 3 then simplifies to equal 1, because 3 divided by 3 is 1. So I'm left with just z plus 4 minus 18, because 6 times 3 is 18. Can't forget about that sign to bring down. Now 3 goes into 3 one time. So we're left with a 2 still, so we can't forget about that. So we're going to bring that 2 down, multiply that by 5 minus z still. Alright, we're going to have to distribute over here, and I'm going to go ahead and combine my like terms at the same time. So I would then have z minus 14 equals 10 minus 2z. Alright, I'm going to combine my variables, so I'm going to add 2z to both sides, so then it stays positive. And so now I have 3z minus 14 equals 10. Now I'm going to look, I have my one term by itself over here, so I need to figure out its like term. Well, it doesn't have a z, so it has to combine with 14, so we're going to add 14 to both sides. And 3z equals 24. Then we divide by 3, and z equals 8. Alright, so say the denominators were not the same, we would then have to, depending on what the numerator is, you could divide both terms in the parentheses by the denominator, or you just multiply the fractions out. Okay. Alright, now we have some systems to solve. You will have one system to solve on the test. Alright, so I have 6x is equivalent to y. Therefore, I can sub it in for y because it's the same. So, 4x plus 6x equals 7. Well, then I end up with 10x equals 7. Divide both sides by 10, and I get a lovely x equals 7 over 10. And we can just stop there. So now I need to plug this in for x. You can pick either one, but I think it'll be easier for me to just multiply this number by 6 rather than trying to combine it there. So y equals 6 times 7 over 10. So I'm going to take 6 times my numerator, and so I would end up with y equals 42 over 10. Now can I reduce that fraction? Yes, I can. I can reduce it to be y equals 21 over 5. I just divided both terms by 2. And there are our answers. Alright, next we have y equals 3x. I can sub that in for y. So I have x equals negative 2 times 3x plus 70. X then equals negative 6x plus 70. Now, which one is my like term? Well, negative 6x is my like term with x. So I'm going to add 6x. So I end up with 7x equals 70. Divide both sides by 7, and x equals 10. Well, now we get to plug that 10 in for x in one of these equations. I'm going to plug it in to the first one because less work. So y equals 3 times 10. So y equals 30. Not too bad. Alright, Now let's do this word problem. So Claire starts with $100 in her savings account and then adds $10 a week. Noah starts with 30 and then he adds 20 a week. Alright, so for Claire, she starts with $100. So I'm just going to write 100. And then she adds, so they even tell us we're going to add $10 per week. And so since the $10 increases per week, we're going to connect our variable to the 10, because say we want to know what it is after the third week. Well, they make $10 a week, so we have to add that in there. Now Noah, he starts with $30 and then adds $20 per week. So same concept there. This one's pretty darn close to your guys' test, okay? So please make sure you do this. Okay, so after 4 weeks, who has more money? So we're going to plug in 4 to each of our equations. So 100 plus 10 times 4, because I'm plugging in 4 for x, then equals 100 plus 40, which then gives us a grand total of $140 in Claire's account. Now we're on to Noah. He starts with 30, and then 20 times 4, since we're still thinking about 4 weeks. So now we have 30 plus 80, which gives us a grand total of $110. Now which one has more? I got excited. It would be Claire. Claire has the most money. Alright, now after how many weeks will Claire and Noah have the same amount of money? Keyword there is same. Same means equal. So we're going to set our equations equal to each other. So 100 plus 10x equals 30 plus 20x. I'm going to subtract 10x from both sides. 100 equals 30 plus 10x. Which one's my like term with the 100? 30 is. So I'm going to subtract 30 from both sides. And 70 equals 10, which I wrote to look just like 70, so sorry for that confusion. There we go. Now we're going to divide both sides by 10, and x equals 7, so it would be 7 weeks. And to explain that is, well, we set both equations equal to each other to figure out when they would be equal. Okay, now onto this one. So all chickens have 2 legs, and then all cows have 4 legs. And there's a total of 82 legs. I'm going to sneeze. Sorry about that. Okay, so there's a handful of ways, as in 2, I guess, ways you could do this. You could plug in 35 into our equation here and solve for the missing variable. So let's go ahead and try that way. So 2 times 35 plus 4y equals 82. That equals 70 plus 4y equals 82. We're going to subtract 70 from both sides. And 4y equals 12. Divide by 4. And we end up with 3 cows. So that is one way you can do this. Or you can just kind of work through it without actually setting up an equation. So we have 7 chickens. Well, that means we have 14 chicken legs. Alright, well, if we know we have a total of 82 chicken legs and we take away the 14 that we have from the chicken, that means we then have 68 cow legs. Fun. Alright, so now we don't want to know how many cow legs there are, we want to know how many cows there are. So we're going to divide this by the amount of cow legs each cow has. So then we end up with 17. So we did the exact same thing